All right, hello friends. Today we're going to learn about something that you have probably never heard of before. They are called imaginary or complex numbers. So my question says, what happens when we try to take the square root of a negative? We can't. So far we know that if we try to take a square root of like -4 or something like that, we cannot do it until now. Now we can. So what I is, it's called an imaginary number, the letter I. And it represents square root of -1. So that's what I represents. Okay, so what about if we take that I, we square it, we also have to square this side. Okay, what happens if we do that? Well, the square roots and the square cancel, and we just have -1. So I squared is -1, and regular I is the square root of 1. So let's look at this chart. We have I to the first power, I to the second power, I to the third power, I to the fourth power. So we already know I to the first power is just the same thing as I, which we said was square root of -1. So I to the first power is just I. I to the second power, we said up above, was -1. So those we already knew. What happens if we multiply those two together? We'll get I to the third. So we multiply them. I times -1 is -I. And if we multiply the I squareds together, we'll get I to the fourth, and it is 1. So all of the other ones, if we go down here and say I to the fifth, it's going to be the same as I to the first. I to the sixth is going to be the same as I squared. I to the seventh is going to be the same as I to the third. And I to the eighth is going to be the same as I to the fourth. And same on. You could say 9, 10, 11, 12, all the way up. Okay, but basically, after 4, you don't have to write that. I'm going to erase it. After 4, they just repeat back to 1. Okay? So what if we have to we have to simplify these huge numbers? 6, 20, and 31. What if we have to do that? Well, we can't write it every single time out. There is a faster way. There's a faster way. So the faster way, the hint, is to divide the number, by 4, because there's 4 different options. So if we divide by 4, we should get the answer. So this answer will be a decimal. If it's 0.0, if it's just a whole number, we know that it's 4. However, if you have a decimal, it's going to be different things. So if it is 0.25, it's the same as I. If it's 0.5, it's the same as that, or 0.50, same thing. And if it's 0.75, it's going to be the same thing as that. Because this is a quick, the shortcut to, instead of writing them all out, 1, 2, 3, 4, and then go back, 5, 6, 7, 8, go back, all that. Now this is our shortcut. So here's what we do. Let's do example 1, I to the 31st power. All we do is we say 31 divided by 4. Make sure it's in a decimal. It is 7.75. So 7.75 means it's -I. And that's it. So now let's do 20. 20 divided by 4 is 5, a whole number. So 5.0, in other words, and that corresponds to 1. Last but not least, we have 6. 6 divided by 4 is 1.5. So 1.5 or 1.50 corresponds to -1. And I'm using my chart up there to help me. Okay, so you're going to have some problems like that. Those aren't too hard. Just divide by 4 and use your chart to help you. Let's move down a little bit. So we said we can't take the square root of a negative. Well, now we can. So we know the square root of, I'll write it again, square root of negative 1 is I. I didn't write that very good. The square root of negative 1 is I. But what about all these other numbers? Over here on the right, I'm going to box it in with my highlighter. I reminded you of all the perfect squares. So these are all the perfect squares, and what happens if you square root them, what they get. Just to remind us to help us on these problems. So let's do example 4, the square root of negative 9. This can be broken down into 9 and negative 1, right? So we just separated because 9 times negative 1 is negative 9. And look over here on your chart. Is the square root of 9 a perfect square? Yes, it is, and it is 3. And the square root of negative 1, we wrote it up above, is I. So that's your answer for that one. You break it up, and then you take the square root of each thing. So let's do this one. Break it up. 16 and negative 1. Is 16 over there on our list? Yes, it is. So the answer is 4, and the square root of negative 1 is I again. Those aren't too bad. Okay. What about 50? Break it down. Square root of 50, square root of negative 1. And let's look and see if it's over there. Is it over there? 49 is, but not 50. So here's what we do. Is there another one of those that goes into 50? 25, right? 25 goes into 50. So let's break 50 up into 25 and 2, because 25 times 2 is 50. So we broke that up, but we still have our negative 1. Okay, so 25, the answer, square root, is 5. The square root of 2 doesn't come out. It just stays like that. And square root of negative 1 is I. The I likes to be buddied with the first number, not the second number. So that's why you have to keep it there. It does not go underneath the radical. Let's try 12. Break it down. 12, negative 1. Is 12 over on our list? No. But is there a number that is on our list, on the left side of the list, that goes into 12? 4 goes into 12, doesn't it? So 12 can be broken down into 4 and 3. We still have our negative 1. Okay, the square root of 4 is 2. The square root of 3 is just square root of 3. And the square root of negative 1 is I. All right, we did this before. Examples 6 and 7, we did that before, but I was quarantined and I had to teach over Teams, so you might not have understood it fully, but that is called simplifying radicals, and we have done it before. So let's try number 8. Number 8, we have square root of negative 3 times square root of negative 12. This is really easy. All we have to do is multiply them together. So 3 times 12 is 36. So we have square root of negative 36. And that can be broken down into 36 and negative 1. Is 36 on the list over there? Yes, I see it. It's right here. So 36 square root is 6, and then the square root of negative 1 is I. Oops, I forgot to put a box around my answers. All right, so the first two, example 4 and 5, those are kind of easy, but the rest are a little bit difficult, so if you are having trouble, just let me know. We have one more thing we want to talk about today, and then we'll be done. What if it tells us to solve? We've talked about solve before with quadratics. It means to get the x by itself so that it says x equals something. So we want to get that x by itself. Let's start with the first one. Get the x all alone. Here it is. We want it to be all by itself. So take the 64 over. It's positive, so we subtract it. X squared equals negative 64. Okay, we have one more step that x still isn't by itself. It has the squared with it. So the opposite of a squared is a square root. Take the square root of the left, take the square root of the right. Those will cancel. And we have x equals square root of negative 64. Oh no! We have a square root of a negative. We would say no solution before, but we can solve this. Let's look back up at our chart. Is 64 over here? It is. It's right here in green. So it's going to come out as 8. So x equals 8i. And because we have a 64, we can have a positive 8 or a negative 8, because 2 positive 8s make 64 and 2 negative 8s make 64. So that's what that means right there. It means positive or negative. Okay, let's go over to this side and try this one. Again, we want to get the x all by itself. So first, let's subtract the 100. Cancel. Bring the 4x squared down. 0 minus 100 is negative 100. Okay, the x still is not by itself. So let's divide by 4. X squared equals negative 100 divided by 4 is negative 25. And the x still isn't alone. One more step. Square root both sides. Square root and square root. Now these will cancel. And we have x by itself equals square root negative 25. Is 25 on this list? It is in the purple. Right there it is. So it comes out as a 5. So x equals 5. Remember, plus or minus. And don't forget your I, because we have a negative. So that is part 1 of these numbers. It's very new, so I understand if you need help, just join me on Teams this week.